Hello boys and girls, so we have question 15. We are given figure 1.12, refer to figure 1.12. We have an unknown charge is placed at point A between two parallel plates. So this particle with the unknown charge, we don't know whether it's positive or negative, is released from rest and accelerates towards the other plates. So the particle will emerge through the hole at point B with the velocity v. So the potential difference between the plate is given 100 volts. Question A, which plate, the top or the bottom, is positively charged? So class, how we are going to answer question A? How we are going to know that which plate, the top or the bottom, is positively charged? We refer to the potential given. So refer to the value of potential given. So the 100 volt here showing that this is a higher potential, and the 0 volt at the bottom plate is at lower potential. Nilai dia lebih kecil kan? So we know that the top plates with higher potential will be positively charged. And the bottom plates with lower potential will be negatively charged. Okay, so means that here will be negatively charged. Here is positively charged. Clear? So we have answered question A, so I put it here. So for question A, the top is positively charged. Why? Because, okay, we put the reason also lah. Because it at higher potential, 100 volt, compared to the bottom plates. Alright, then done question A. Proceed to question B. Identify the charge, proton or electron, of the unknown particle. Justify your answer. So class, this particle is unknown. We didn't know about the charge, whether it's proton or electron. So kita nak dapatkan sama ada unknown particle ni proton charge means it's positively charged, or electron negatively charged. Okay, so how we are going to determine particle tu proton or electron? Kita akan refer kepada electric force that acting on that particle. Okay, I repeat, we will refer to the force that acting on that particle. Okay, so class, so we know that the parallel plate, the top plate is positively charged 100 volt, the bottom plate is negatively charged at 0 volt. So it means that due to this potential difference, because of the potential difference between the two plates, we will create electric field. So we are going to create electric field in between the two parallel plates. We will create uniform electric field E in between the two plates. And then for this unknown particle, when we put it in electric field, it experience electric force. So, kalau kita refer kepada sentence given, we find out that this particle accelerate towards another plate, whereby upon release from plate A, this particle accelerate towards plate positive. So, if it accelerate towards plate positive, means that this particle have a electric force that attract it to the top plates, which is positively charged. So kalau dia attract kepada positively charged plates, it means that this particle must be a electron. So the unknown particle is an electron. Why? Because, why? Because the electron accelerate upwards towards the positively charged plate. Indicates that it experiences electric force upwards. So, kalau dia rasa electric force upwards, dia ditarik ke arah positif, kita understood, dia mestilah charge negatif. Dia mestilah charge negatif. Barulah dia akan rasa attraction force ke arah plate positif. Okay? So, understood ah? So, we done with question B. Then we move on to question C. So, question C, we want to calculate the electric field strength E. So, like what I said just now, because of the potential difference between the two plates, we create a uniform electric field in between the plate. So, we want to determine the electric field strength E. So, this electric field strength we can relate with the separation between the plate and also the potential difference delta V between the two plates. Okay, so I put it here. So for question C, we might calculate the electric field strength by using equation delta V over D. Okay, so the potential difference between the two plates is 100. How we get 100? Because the upper plate is 100 volt minus the lower plate is 0 volt. So we get 100 lah. Then the separation is 0.1. So I'll get the electric field strength is 1000 Newton per Coulomb. Okay. Then we solve question C. Then question D, calculate the acceleration of the charge after it have traveled from A to B. So class, we understood that this electron experience a net force which is equal to the electric force. So it have an acceleration. It will have acceleration towards the plate B. So we want to determine the acceleration. So in order to determine the accelerations, we might apply Newton's second law. Summation force equal to ma. So the net force that acting on the electron is the electric force. So electric force equal to ma. So rearrange the equation. I can calculate the acceleration whereby I have the electric force divided by the mass. The electric force acting on the electron can relate with the electric field strength. So electric force is Q multiplied E over the mass. So I put in the value. So the elementary charge for one electron. So satu biji electron, berapa charge dia? You might refer to the list of constant. The elementary charge for one electron is 1.6 to the power of negative 19. So the electric field strength of the parallel plate we can take from the answer we calculate in question C, 1000 over the mass of the electron. The mass of the electron also we can refer to the list of constant. So mass of electron is 9.11 to the power of negative 31 kilogram. So you might pause the video to calculate the accelerations of the charge. So if you do the calculation correctly, you might get your answer should be 1.76 to the power of 14. So unit for acceleration is meter per second squared. Okay. So we're done with question D. E. What is the time taken for the charge to move from A to B? So class, if we refer to the questions, so this charge will do straight line motion from point A travel to point B. So we want to calculate the time taken to travel from A to B. So we know that the distance between point A and point B, the distance between point A and point B is 0.1 meter, and the particle is released from rest. So if it is released from rest means we understood the initial velocity is 0. So the distance traveled from A to B s is 0.1 meter. The acceleration experienced by the particle is already determined from question D. So it's doing straight line motion. The charge is doing straight line motion, so we can apply kinematics equations. So we know that our u is 0, our s is 0.1 meter, and the acceleration experienced is 1.76 to the power of 14 meter per second squared. We want to determine the time taken to travel from A to B. So we might use kinematic equation as is ut plus half at squared. So since u is 0, so this one can be cancelled. So I'm going to have 1 over 2. The acceleration is 1.76 to the power of 14. The time we would want to determine the distance traveled from A to B is 0.1. So again, you might pause the video to do the calculations. If you calculate correctly, you should get 3.37 to the power of negative 8 seconds. So bear in mind, always include the unit after the answer. Okay, then we solve question E. We proceed to the last question. Calculate the value of V. So we want to determine what is the final velocity or the value of V as the particle emerged at point B. So we want to find the velocity, the final velocity at point B. So in order to find the final velocity at point B, again, we are going to apply kinematic equation because the charge is doing straight line motion, linear motion. So we might have V equal to U plus AT, the most basic kinematic equation. So our U is 0, whereas starting the particles is at rest. So the acceleration is 1.76 to the power of 14. Okay, the time taken to travel from point A to point B is already determined from question E, 3.37 to the power of negative 8. So you might pause the video to determine the V. So if you do it correctly, you might get the V as it emerged from point B will be 5.94 to the power of 6 meter per second squared. Meter per second for velocity. Okay, then we solve question 15. So there are another 2 questions in your tutorial that quite similar to the concept given. So you can try on your own. You might try question 12 and question 13, which is related to learning outcome 1.4, the motion of charge in uniform electric field, to enhance your understanding. Thank you. See you on next video. Bye bye.